this learning goal is I can apply the kinematic equations in 2 dimensions to solve a projectile motion problem. Okay, so in this problem we have a gun, and that gun is fired, it says, at a height of 1.6 meters above the ground. And the wall is going to be 10 meters away. It also tells us the bullet leaves the gun moving 400 meters per second. How far does the bullet fall vertically before hitting the wall? So really the question is, how far does the bullet fall vertically? Meaning, at the height that it started at, how much lower is it now? What is this distance? Now this is in the y direction, so we'll call this the change in y. So hopefully you've noticed, okay, this is a projectile motion problem. As soon as the bullet leaves the gun, the only force acting on it is the force of gravity. It's in free fall. So we can apply the kinematic equations. Okay, so it's always good to start with what we know and what we don't know. And let's look in both the x and the y direction. So set up our table. In the x direction, the bullet travels 10 meters. So that's the change in position. The initial velocity, notice, it's not shot on an angle that has both an x component and a y component. It's shot just in the horizontal direction. We only have an x component for the velocity. So that's going to be 400 meters per second. Okay, what can we say about the acceleration in the x direction? Well, assuming there's no air resistance, you can say the acceleration in the x direction is 0. And in the y direction, the acceleration is acceleration due to gravity, which is 9.8 meters per second squared. Do we know anything else? Well, if we look, we said our velocity is only in the x direction. We don't have any y components initially. It's just heading in the x direction. So the initial y component of the velocity is 0. What are we trying to find? We're trying to find what is that change in y. What is this value? So with the kinematic equations, if you have 3 variables, you can always find the 4th. Now we're looking for the change in y. So if we had 3 variables in the y direction, then we can just solve for the 4th. But we don't. So we have to first use the x direction to find the time. And then time is independent of direction. So we can use that time in both the x and the y direction. So we got to think, look back to your kinematic equations and try to pick the right one from your notes of what it's going to be. So hopefully you chose this equation. So the next part, let's plug in our values. We've got 10 meters here, 400 meters per second. We don't know our time. Our acceleration is 0. So 0 times any number just cancels this value. That whole term is going to be 0. So what I'm left with is delta t is equal to 10 divided by 400. So that's equal to 0.025. So it's very fast, but that's kind of what we would expect for a gun only traveling 10 meters. So we know this time is 0.025 seconds, but that's going to be the same time. Again, it's independent of direction. So what we can use is that time that we just found, along with these 2 knowns, to find this final unknown. If we look, we have the same variables as before, so we can use the same equation as before. Delta y is equal to v I y delta t plus 1/2 a. And now our acceleration is in the y direction. So let's find what our change in y is. initial velocity of the y is 0, negative 9.8 for the acceleration, and the time we just found was put that in our calculators. Get 0.003. So this bullet would not drop very far if we're only 10 meters away from a wall. It would only drop a total of 0.003 meters.